Hi, and welcome to the video for section 12.3. Again, this will be only one video for this section. So section 12.3 is on geometric sequences. So 12.2 was arithmetic sequences, that was addition. Geometric sequences, geometric is our code word for multiplication. So as we go from one term to the next, to the next, to the next, we're multiplying it by some value. And we saw this in video 1 where we had like our starting value was -2, and then we went to +4, then -8, and so forth. Hopefully you remember that sequence. That was a geometric sequence. So we have the following definition. A geometric sequence is of the form so A, our starting value, and then A times R, the value we're multiplying it by, and then A to the R squared, then AR to the third, and so forth. Every term we keep multiplying it by that value R. So A is our first term, as I mentioned. R is what's known as the common ratio. So in the arithmetic sequence, we have the common difference, just the value, thus the value D. Now we have the common ratio. How much are we multiplying by each time? That's our value R. And so our formula for this one, and again, this is absolutely a cheat sheet item. So the nth term is given by A sub n is equal to A times R to the n minus 1. So let's look at a couple examples here. So similar to our first example with the arithmetic sequence, we have the following. If A is equal to 3 and R equals 2, we want to find the sequence. So we have what? Our first value is 3. Our second value is 3 times 2 to the first. So we're just using this formula. A is 3, our ratio is 2, and because it's the second term, 2, so here's A of 1, A of 2. So we plug in 2 anywhere we have an n, so we get 2 to the first. And then 3 times 2 squared, and 3 times 2 to the third, and so forth. So if we calculate those, we get 3. 2 to the first is 2 times 3 is 6. 2 to the squared is 4. 4 times 3 is 12. And you can see what's happening. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48, and so forth. So that would be our sequence. Every time we move to the next term, we're just multiplying the one before it by 2. All right, let's look at this example. So we want to find the 8th term of the geometric sequence 5, 15, 45. So they gave us a little hint. They already told us it's a geometric sequence. On an exam, this might say find the 8th term of this sequence and then give you that. So you have two options. It's either an arithmetic sequence or a geometric. So if it's arithmetic, that means what? 5 going to 15 means I had to add 10. That would be my difference. So if I add 10 again, that would mean this value should be 25, which is not. So I know it has to be a geometric sequence. So then I ask myself, when I go from 5 to 15, what did I have to do? I had to multiply by 3. And from 15 to 45, I had to multiply by 3. So my starting value is what? 5. My ratio, the R value, is what? It's 3, that value that we multiply by each time. So that means that A sub n is A, which is 5, times the ratio 3 to the n minus 1 power. So now I figured out the general form. So if I want the 8th term, A of 8 is equal to 5 times 3 to the 8 minus 1. 8 minus 1 is 7. So you crunch these numbers on your calculator. This ends up 10,935. So you can see these numbers can get big in a hurry, these geometric sequence. So as such, we will generally try to use arithmetic sequences. Those are a little easier to calculate for you guys as opposed to, huge multiplication numbers. Obviously 3 to the 7th, you can't do that without a calculator. You could, but it's going to take you a long time. So this is a good homework problem, not such a good exam problem where you're not allowed to use a calculator. So let's look at one more example. So the first term of a geometric sequence is 8. The second term is 4. Find the 5th term. So I'm going to let you try this one on your own. Go ahead and hit pause. Work it through. Try to figure out, when we know our starting value, that's 8. So we need to figure out our R value. Once we have that, we can write the generalized form and then calculate the 5th term after that. So go ahead and hit pause. Try to work that through. Come on back and we'll work it out together. All right, welcome back. So if we go from 8 and the next term is 4, we know this is multiplication. So what do I have to multiply 8 by to get to 4? Well, I have to multiply it by 1/2. So that R value doesn't have to be like a natural number, a counting number. It could be a fraction, it could be a decimal, it could be anything. So that means that A sub n is our A, which is 8, times 1/2 to the n minus 1. So I want the 5th term, so that means A sub 5 is 8 times 1/2 to the 5 minus 1 is 4. And so again, you calculate these numbers, you should get that A sub 5 is equal to 1/2, or 0.5 if you use the calculator for it. Okay, so last part of 12.3 is similar to the last part of 12.2, which was the partial sums. So again, these numbers can get really nasty quickly. So again, the typical exam problem is going to be like the example I told you about with the starting salary. It goes up, how much after 20 years, things like that. But the formula for partial sum of a geometric sequence is as follows. Only one for this, and that's S of n is A times 1 minus R to the n all over 1 minus R. So again, because of this R to the nth term, this number is going to get messy. If we're trying to figure out, let's say, S of 10, the first sum of the first 10 terms, Well, even if my r is just 2, if I'm just doubling every time, that becomes 2 to the 10th. That's a big number. So you can see it's really difficult to kind of give a exam problem here when you don't get to use a calculator. So that's it. That's 12.3. Again, the only video with regards to this section. Come on back. We'll tackle section 12.5.